Now paper number 10437. 10437. Now this is NIACL AOs. Now question number 66 to 70. Now these 5 questions are based on 2-row arrangement. How many persons are there? There are some 12 people. And who are those 12 people? M, N, O, P, Q, R, A, B, C, D, E and F are the 12 people. Now these 12 people are seated in 2 different rows. 1, 2, 3, 4, 5, 6. This is one row and this is row 1. Who are the persons in this row 1? M, N, O, P, Q, R. M to R are the persons who are in row 1 and these persons are facing towards south. And there is another row opposite to this one and the persons in the second row are facing towards north. And A through F are the persons in the second row, they are facing towards north. Faces another member of the other row. B faces the one who sits out to the right of Q. Now condition number 1, B is facing the one who sits out to the right of Q. Then tell me how many possibilities do we have. Now if Q is here, B sits out to the right of the one who is opposite to Q means 1, 2, 3. Now right hand side of Q is this person and B faces this person. This is one possibility. B is facing the one who sits out to the right of Q. And there is one more possibility. What is the second possibility here? 1, 2, 3, 4, 5 and 6. Now if Q is at the second place, then 1, 2, 3, 4, 5 and 6, B will be at this place. And B does not sit at any of the extreme ends of the line, hence we are having only 2 possibilities. Then condition number 2, only 3 people sit between Q and N. Now between Q and N, tell me how many persons are there? There must be exactly 3 people, N must be here. Now in this one, in the second case, N must be here. There are only 3 people between Q and N. R is neither an immediate neighbor of N nor Q. R is not adjacent to N or Q. As R is not adjacent to N or Q, hence in the first case R must be here. And in the second case R must be here. R is neither an immediate neighbor of N nor Q. One of the immediate neighbors of R faces F. One of the immediate neighbor of R faces F. Either this person is facing F or this person is facing F, out of which this person is facing B but not F, hence F must be here. One of the immediate neighbors of R faces F, hence F must be at this place. Only 3 people sit between F and the one who is facing O. Only 3 people between F and the person who is facing O, hence O must be here. And in the second case is not possible because there are only, at the most there are only 2 persons in between F and the one who is facing O. And the second case is ruled out, now we are left with only first possibility. And A sits second to the left of the one who is facing M. Now A. Now A is seated second to the left of the one who is facing M. A cannot be at this place. Can A be here? If A is here, then M and Q must be in the same place, which is not possible, isn't it? Because A sits second to the left of the one who is facing M. Hence, A cannot be here, A cannot be here. Then what is the only possibility here? Then, or else if you take M at this place, M can be either here or here, there are only 2 possibilities. If you take M at this place, opposite to M is F and second to the left hand side of F must be A. But as here B is there, hence that is not possible, which implies that M cannot be at this place. As M cannot be here, then what is the only possibility here? M must be in between N and R. M is here, opposite to M is B. Now this A is seated second to the left hand side of B, that is A is at the corner. Then in the first row, who is the person left over here? P is the person left over. And in the second one, A sits second to the left of the one who is facing M. C is not an immediate neighbor of B and C cannot be in these 2 places, hence C must be to the immediate right hand side of F. N does not face E. N is not facing E, hence E must be here. And the person who is left over is D. D must be at this place. Done with this? Now this is about set number 1, question number 66 to 70. 12 people in 2 different rows. Let's write down this arrangement. Question number 66 to 70. ONM, RPQ, and the second row is A, D, B, E, F and C. Then question number 71 to 75. Now in this 71 to 75, 8 people L, M, N, O, P, Q, R and S are sitting around a square table. How many persons are there? There are only 8 people, and these 8 people are seated around a square table. Now this is the square table, 4 persons at the center and 4 at the corners, 4 at the center and 4 at the corners, and the one who sits in the middle of the sides facing the center. Middle of the sides faces the center, all these persons are facing towards the center, and the persons who are at the corners are facing away from the center. Middle of the sides are facing the center, and the persons who are at the corners are facing away from the center. R sits out to the right of P. P sits at one of the corners of the table. As P is at one of the corners of the table, now we can fix this P at any one of these 4 corners. Now I am fixing this P at this place. Now if P is here, R sits out to the right of P. As P is away from the center facing outward, R sits out to the right hand side of P, then right hand side will be in the clockwise direction. R sits out to the right of P, P sits at one of the corners of the table. Only one person sits between O and R. As only one person between O and R, tell me how many possibilities we can have. Either O can be at this place or O can be at this place. There are 2 possibilities. And only one person between O and R. M is one of the immediate neighbors of O. As M is one of the immediate neighbors of O, hence M can be either at this place. These are the 2 possibilities. Hence here M can be here as well. In total there are 3 possibilities to this M. And only one person between O and R. M is one of the immediate neighbors of O, and N sits second to the right of M. As N is seated second to the right of M, now if you take M at this place, then N sits second to the right of M, it is possible. Or if you take M at this place, N sits second to the right of M, it is also possible. Then what is the other possibility here? If M cannot be at this place, because if M is here, N and P must be in the same place, which is not possible. Hence finally, among those 3 possibilities to this M, finally we are having only 2 possibilities to this M. And N sits second to the right hand side of M, only 3 people between M and L. As only 3 people between M and L, hence M and L must be opposite to each other. As M and L are opposite to each other, M cannot be at this place, isn't it? Because if M is here, M will be opposite to P rather than to L. Hence M cannot be at this place, hence M cannot be here. Then what is the only possibility we have? Hence M must be in between O and R. This is the only possibility left out to this M. M is here, N sits second to the right of M, N will be here, and 3 people between M and L, hence M and L are opposite to each other. S sits to the immediate right of L, and this is S. This information is not at all required. Done with this? Now this is how these 8 persons are seated around this square table. 4 are facing the center and 4 are facing away from the center. 71 to 75. Yes, shall I explain the questions or not required? 71 to 75 questions, please. Questions. Then 76 to 80. First write down this arrangement, then let us discuss about this 76 to 80. Now in this 76 to 80, these 5 questions are based on input and output. 76 to 80, input and output. When a word and number arrangement machine is given an input line of words and numbers, it arranges them by following a particular pattern or particular rule. The following is an illustration of input and its rearrangement. All the numbers are 2-digit numbers. Yes, what is input here? Baffled 46, iceberg 19, nation, unreal 75, 28, kidney 63, abandoned ends 94. Hence, tell me how many elements are there in the given input here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. In total we have some 12 elements given in the input. How many steps are there? 6 steps are there. 12 elements given in the input, 6th step is the final output. Hence, in each step exactly 2 elements are being arranged, isn't it? In each step 2 elements, hence 2 into 6, 12 elements will be arranged by step 6. Now first let us finalize the logic behind this one. In order to find out the logic, we should always compare the input with the final output. What is input here? Input, and the final output is step 6. Now if you compare these two, now first 1963, 75 are the three numbers arranged in the ascending order. What are these three numbers? 1963, 75, all these are odd numbers. First odd numbers are arranged in the ascending order, followed by at the last place 28, 46, 94 even numbers are arranged in the ascending order. Clear now? First three numbers odd numbers ascending order, and last three numbers even numbers in the ascending order, isn't it? 28, 46 and 94 are the even numbers, they are arranged in the ascending order. Then coming to these words, unreal, iceberg and abandoned. Now it started with unreal, but whereas they were not in the descending order, isn't it? But whereas it started with U, this is I, this is A. What are these three? These three are vowels. And the words which are started with the vowels are arranged in the descending order, followed by the words which are started with the consonants in the descending order. Numbers in the ascending order, words in the descending order, first vowels followed by the consonants. Done with this? Then the pattern. What is the pattern here? Now in this pattern, first which element has been arranged at the first place? Abandoned. And next one, baffled, 46, iceberg, 19, unreal and so on. And finally, what is the other element which is arranged here? Nation. That means vowel, least word, and now this one, the highest consonant. Then abandoned shifted to the next place, nation shifted to the next place. Next abandoned third place, nation third from the right, abandoned fourth place, nation fourth from the right, fifth place, fifth from the right, finally sixth place and sixth place. And from there onwards, now these vowels are shifting to the right hand side and the consonants are shifted to the left hand side. Then after this step 1, then the next vowel, what is the next vowel here? Iceberg. And the previous consonant is kidney. Now these two were arranged at the last places. Further they were shifted to the left hand side and right hand side in each of the following steps. Clear now? Now this is how these elements were arranged in 6 steps. There are 6 words and 6 numbers. Done with this one, 76 to 80, the logic and the pattern in this one. Then 81 to 85. Now in this question numbers 81 to 85, these questions are based on syllogisms, 3 statements followed by 2 conclusions. Now first statement, all fares are prices. First we are drawing the basic diagram. All these fares are prices. All fares are prices. Some of the prices are cost, some prices are cost. This is the basic diagram. And all costs are what? All these costs are tariff. All fares are prices, some prices are cost and all costs are tariff. Then what is the first one here? No fare is a tariff. No fare is a tariff is true as of now. And the second one, no cost is fair. No cost is fair is also true, isn't it? Hence, now both the conclusions followed from the basic diagram, and these 2 conclusions which followed from the basic diagram, these 2 are negative conclusions. As the negative conclusions follows from the basic diagram, now we need to prove the complementary pairs to each of these one to check out whether they can be false at least once or not, isn't it? Now in this one, no cost is fair. Now in order, hence we should draw a alternate diagram. What is the complementary pair to this one? No cost is fair, some of the costs are fair. Then how to draw this one? Some costs or fares can be written like this. If some costs or fares are like this, then all costs are tariff. Then tariff will also come like this, isn't it? Now this is the alternate diagram to the negative conclusions. Then according to this alternate diagram, check out whether the statements are valid or not. All fares are prices is valid, and some prices are cost is also valid, and at the same time some prices are cost is valid and all cost or tariff is also valid. All the 3 statements are valid. At the same time, no fare is a tariff has become false because I have proven some of the fares are tariffs. As some fares are tariff is true, no fare is a tariff will be false. Alternate diagram proven, previous conclusion will be false. Clear? Then coming to the second one, no cost is fair. No cost is fair means in order to prove this one false, now we have drawn the complementary pair, that is some cost or fares is true. As some cost or fares is true, no cost is a fair will be false. Then what is your answer here? neither 1 nor 2, choice 2 is the answer. Alternate diagram proven, previous negative conclusion will be false. Then question number 82. And again, if you check out here in question number 81, all the statements are what? All the statements are affirmative, and these two conclusions are negative conclusions. Hence, a negative conclusion cannot be drawn from the affirmative, and straight away you can make it as neither 1 nor 2. Then question number 82. Now in this 82, some of the tests are examinations. Some tests or examinations can be written like this. Some tests are exams. No exam is a challenge. No intersection between exam and challenge. And some of the challenges are wins. Some challenges are wins. This is the basic diagram. Then first conclusion, no test is a win, definitely true. And the next one, some tests are wins. Some tests are wins is false, because test and win, these two are apart. Then coming to this one, the first conclusion is true and it is a negative conclusion. As a negative conclusion is true, to make this one false, now we need to draw the complementary pair. What is the complementary pair to this one? No test is a win, some of the tests are wins. Tell me whether we can prove like that or not. Some tests are wins can be written like this. Now this will be win. If this is win, and this will be cost. Isn't it? Challenge. Some challenges are wins. Now, according to this basic diagram, now see here. Now in this alternate diagram, no test is a win has become false, because I have proven a case wherein some of the test or wins is true. As some test or wins is true, no test is a win will be false. Alternate diagram proven, previous negative conclusion will be false. After making the previous negative conclusion false, then we should check out the affirmative conclusion which was false in the basic diagram. Why? In order to check out whether either or is there or not. Now what happened to the second conclusion in this alternate diagram, tell me? Now some tests are wins, some tests are wins has become true. Now the second conclusion has become true. When the first conclusion is true, second has become false. First one is a negative conclusion. When the negative conclusion is false, now this affirmative conclusion has become true. Then what is your answer here? Either 1 or 2. Clear now? It is the case of either 1 or 2, that is choice 5. Alternate diagram proven, previous negative conclusion will be false, then its complementary pair has become true. Hence either the first one can be true or the second one can be true. Between these two, which is definitely true, we are not sure about this one, hence it is the case of either or. Then question number 83. Now question number 83, some tests or exams. Some of the tests or exams can be written as like this. Some test or exam. No exam is a challenge, and some challenges are wins. No exam is a challenge can be written like this, and some of the challenges or wins can be written like this, basic diagram. And first one can never be. Can never be is nothing but a possible conclusion. And second one, no win is an exam. As no win is an exam is true, now the second one is a definite conclusion, it is true. In order to make this one false, now we need to prove some wins or examinations. Tell me whether we can prove like that or not, some wins or examinations. Now win and exam, tell me whether we can draw like this or not, some win and exam. Examination and this challenge should not be intersected. Now win and challenge can be intersected, isn't it? Hence alternate diagram proven, hence previous conclusion will be alternate diagram proven, previous conclusion will be false. Done with this? Then coming to the first one, all tests can never be challenges. Yes, how to represent this one? All tests can never be. Can stands for what? Can stands for a possibility, never means negative. Hence the same thing can be written as all tests or challenges, all tests or challenges is not possible, isn't it? Can never be should be written like this. All tests or challenges can never be possible, isn't it? Now first let us check out whether all tests or challenges is possible or not. Now these are the tests, all tests or challenges, now I am checking out whether it is possible or not. Now tell me whether I can draw challenge like this. If you draw challenge like this, then what is the statement here? No exam is a challenge will be false, because exam and challenge has become intersected with each other, isn't it? Hence statement is invalid. A statement is invalid. For me it is not possible. All tests or challenges is not possible. His claim is also that all tests or challenges is not at all possible. Then what is your answer here? Only conclusion 1 is true, choice 3 is the answer. Followed? Here his claim is all test or challenges is not possible. For me also all test or challenges is not possible. Hence whatever his claim, it is true. Then question number 84. Now in this 84, no proof is an evidence. No proof is an evidence can be written like this, proof and evidence. No intersection between these two, no proof is an evidence. And no proof is an indication. No proof is an evidence and no proof is an indication. Hence, proof cannot be intersected with indication or with evidence. Then first one, all indications. First one is a possibility. Second, no evidence is an indication. No evidence is an indication, definitely true. This is a definite conclusion. Now to make this one false, now we need to prove some evidence is an indication. Tell me whether we can prove like that or not. Some evidence is an indication means evidence and indication must be like this. Whether we can draw like that or not. Hence some evidence is indication, that is definitely true. Hence alternate diagram proven, previous negative conclusion will be false. Then coming to the first one, all indications or evidence is a possibility. All indications or evidence is possible or not? No sir. Possibility means now we need to prove all these indications can be a part of evidence or not. Indication should not be intersected with the proof. Now indication and evidence can be intersected. Hence the first one is possible. Then what is your answer here? Only conclusion 1 is true, that is choice 4. Question number 84, choice 4. Then 85. Now question number 85, all fares are prices. All these fares are what? All fares are prices, and some prices are cost, some of the prices are cost, all costs are tariff, all these costs are tariff. Now this is the basic diagram. All fares are prices, some cost are prices, and all costs are tariff. Then first conclusion, some prices are tariff. Price is here, tariff is here, that is definitely true, some prices are tariffs. Second one, all tariffs are prices is a possibility. All tariffs are prices, all the statements are affirmative. As all the statements are affirmative, for a possible conclusion, we can draw like this. Fare equals to price equals to cost equals to tariff. Hence all these are possible. Both conclusions 1 and 2, that is choice 1. For a possibility, the statements are affirmative, we can draw a universal diagram, that is a single diagram. 85, choice 1 is the answer. Now this is about question numbers 81 to 85, syllogisms. Then 86 to 90. Now question numbers 86 to 90. Now these questions are based on coded inequalities. Now the first one, the relation between K and W. W is here, K is here. Now if you observe here between W and K, there are two opposite symbols, greater than and lesser than. Two opposite symbols cannot be drawn. Hence first conclusion is false. Second one, Y lesser than or equals to W. W is here, Y is here. What is the letter which is common between these two? U is common. Hence U is here, U greater than or equals to Y. W between W and Y, again check out here, there is one greater than, then this is greater than, equal to, greater than or equals to, greater than. Forget about this equals to. Then tell me which symbol is common here? Greater than or equals to is common. Hence W greater than or equals to Y, definitely true. As W greater than or equals to Y is definitely true. Hence Y lesser than or equals to W is also true. Hence which conclusion? Second conclusion definitely followed. Only conclusion 2 follows, that is choice 2. Question number 86, choice 2 is the answer. Then question number 87. Now in this question number 87, the relation between P and S. The relation between P and S, R equals to S. In the place of R, take it as S. S greater than P. Now from the second statement we got that S greater than P. If S greater than P is true, P lesser than S is also true. That is conclusion 1. And coming to conclusion 2, L lesser than or equals to P. L is here, P is here, and the letter which is common between these two is R is common. Hence R is here. Now between R and P, R greater than P is the final conclusion. Now between L and P, if you observe here, there is one lesser than and one greater than, two opposite symbols, hence no relation can be drawn between these two. Then what is your answer here? Only conclusion 1 is true, choice 4. Done with this? 87. Then question number 88, the relation between Y and M. Y is here, M is here, the letter which is common is W is common. Now between Y and W, Y lesser than W, and M and W, M greater than or equals to W means W lesser than or equals to M. Now between Y and M, which symbol is common? Lesser than or equals to. Lesser is common, Y lesser than M is definitely true. Then coming to the next one, first conclusion true. Second one, the relation between S and D. Now W greater than S and W greater than D, as W greater than D, D lesser than W. Now between D and S, how many symbols are there? Two symbols, and these two are opposite to each other. Hence no relation can be drawn, hence S lesser than D cannot be derived. Only conclusion 1 is true, that is choice 4 again. Question number 88, it is choice 4. Then 89, the relation between J and L. J is here, L is here. Tell me which element is common here. P lesser than J, and next one P lesser than or equals to L. P lesser than or equals to L means L greater than or equals to P. L greater than or equals to P, P lesser than J. Now between L and J there is 1 greater than, 1 lesser than, two opposite symbols, no relation. Hence first conclusion cannot be drawn. Then coming to the second one, between S and J, lesser than or equals to lesser than, which symbol is common? Lesser is common. Hence S lesser than J definitely true. Only conclusion 2 is true, that is choice 5. Question number 89, choice 5. Then question number 90, the relation between Y and S. S is here, Y is here. Tell me which element is common here between S and Y. S lesser than or equals to P, and P equals to Q means S lesser than or equals to Q, and Q lesser than or equals to Y. Hence finally what is the final conclusion? S is either lesser than or equals to Y, which implies that Y is either greater than or equals to S. Y is either greater or equals to S, either conclusion 1 or conclusion 2. Hence either 1 or 2, choice 3. Clear? Now this is about question numbers 86 to 90, choice 3 is the answer. Then 91 to 95, 91 to 95 is based on coding and decoding. Now in this coding and decoding, tell me, first we need to compare these statements. The first and the second statement, if you observe here, how many words are common between the first and the second statements? Gloves were found there, and here 2 pairs of gloves. Hence what is the word which is common? Gloves is the only word which is common. As only one word gloves is common between the first and the second statements, then which symbol is common here? VG, XA. XA is common, and the code to the word gloves is XA. Gloves, XA. Then compare the first one and the third one. If you compare the first and the third, were found there and found, which word is common between these two? Found is the word which is common between these two. As found is the word which is common between these two, VG, ZE, CO. VG, ZE, CO. Which element is common? The code VG is common, hence the code to the word found is VG. Then compare the first one and the fourth one. Where, there, here, where. If you compare the first and the fourth, where is the only word which is common between the first and the fourth, and the code which is common between these two is CO is common, and the code to the word where is CO. Then in the first statement you tell me which word is left over? Only one word that is there is left over, and the code which is left over is ZE, and the code to the word there is ZE. Done with this? Then compare the second and the third statements. 2 pairs of, here 2 is the word which is common between the second and the third statements, hence 2. Then which word is code common here? SH is common between these two, hence the code to the word 2 is SH. 2 is SH. Next, pairs and of. Now pairs and of, is there any word which is common between these two? No word. Hence between pairs and of, finally 2 words are left over, pairs and of, and 2 codes are left over. And what are the codes which are left over here? YC and TI. And the code to these words pairs and of will be YC or TI in any order. Next one, found new friends. Now what is the word which is common here? New is the word which is common. As new is the word which is common between these two, and the code which is common between these two will be NU. New is NU. If new is NU, then in the third statement, friends is the word which is left over, and the code which is left over is the code to the word friends is WD. WD is left over. Hence, friends is WD. Finally, we are left with all and packets. Two words are left over, all and packets, and two codes are left over. And what are the codes here? OM and QK. OM and QK in any order. Now, these are the words and their corresponding codes. Done with this? Then question number 91. What does the code TI stands for? The code TI stands for either pairs or of. Either of or pairs, choice 1. Question number 92. What is the code for the word where? Yes, tell me what is the code here? CO. CO, that is given in choice 5. Then question number 93. In the given code language, blue is coded as AF. Now, blue is coded as AF. Then how will all blue packets be coded? Blue is coded as what? AF and all. What is the code to this word? All and packets. Now, these two are coded as OM or QK in any order. And the answer could be OM, AF, QK, OM, AF, QK or AF, OM, QK. That is choice 1. Then question number 94. Now, in this question number 94, what will be the possible code for new winter gloves? New winter gloves. New. What is the code for this word new? NU. And winter. And is there any word winter here? Winter is nowhere given. And gloves XA. Hence, your code must be NUXA. Apart from this one, winter, there is a possible code. As winter is nowhere present in this one, and hence the code to this word winter should be any code other than the given codes. Can be any codes other than the given codes. Now, NUXA. Choice 1 cannot be your answer. Choice 2 there is a possibility. Choice 3 there is a possibility. Hence, your answer could be either choice 2 or choice 3. Now, between these two NUXA, now tell me whether TI can be the code for the word winter or not. No. Why? Because TI is the code to the word either pairs or of. It cannot be the code to the word winter. Hence, choice 2 is also ruled out. Finally, what is your answer here? Choice 3. Now, NUXA, then DY is left over. Now, tell me whether DY can be the code to the word winter or not. Yes, because DY is nowhere given in the given codes. Hence, DY can be the code to the word winter. Choice 3. 94, choice 3. Then question number 95. What will be the code for the word found in the given code language? And tell me what is the code to the word found here? Found is VG. VG, that is choice 4. Question numbers 91 to 95. Then question numbers 96 to 100. Now, 8 people PQRS WXYZ are living on 8 different floors of a building, but not necessarily in the same order. The lowermost floor of the building is called as, is numbered as 1. The one above that is number 2 and so on, floor arrangement. 8 persons living on 8 different floors. Whenever floor arrangement is given, always fix the floors at the center and extend the lines like this. 8, 7, 5, 6, 8, 7, 6, 5, 4, 3, 2 and 1 are the floors. Now, extend the lines like this. If there is a second possibility, we can work out the second possibility simultaneously. Then condition number 1. P lives on an odd number floor below floor number 6. As P lives on an odd number floor below floor number 6, then tell me what are the different possibilities to this P. P can be either on the first floor or on the third floor, isn't it? Hence, there is one more possibility. P can be on the 5th floor as well. As of now, we cannot represent the data here. Hence, let us take 2 different possibilities, P on the first and the P on the third. If these 2 are invalid, then we can directly start with P with 5 and P with 5. Then, Y lives immediately above P. As Y lives immediately above P in first case, Y must be on the second floor, and in the second case, Y must be on the 4th floor. Y lives immediately above P. Only 3 people between Y and W. As 3 people between Y and W, 1, 2, 3, in the first case, W must be on the 6th floor, and in the second case, W must be on the 8th floor. 3 people between Y and W. There are as many people W and R. Between W and R equals to R and Y. between W and R equals to R and Y. Now in this one W and R equals to R and Y between, hence now between W and Y how many places are there? 3 floors are there, isn't it? As 3 floors are there, hence between W and R there is only 1 floor, R and Y there is only 1 floor. And in this one W and R there is 1 floor, between R and Y is also there is 1 floor. Number of floors in between W and R equals to number of floors between R and Y. Z lives on an odd number floor below Y. Z is on an odd number floor below Y. Now in the first case it is not possible because Y himself is staying on second floor, Z is below Y, Z must be on the first floor, but whereas P is already there on the first floor, and this case is completely ruled out. Now we are left with this case. Now Z lives on an odd number floor below Y. Below Y means Z can be either on the third or on the first floor, out of which third is not possible, hence Z must be on the first floor. Z lives on an odd number floor below Y, but not on the floor number 3. Anyhow that information is not required because P was already there on floor number 3. And next one, only one person lives between Q and X. Now between Q and X there must be exactly one, and Q lives above X, hence Q will be here. Only one person between Q and X, Q is above X. Then who is the person left over here? S is the person left over. Clear now? This is how these 8 persons are staying in these 8 different floors. And the order is W, Q, R, X, Y, P, S and Z from top to bottom. Write down this arrangement. Is done. This is about question number 66 to 100. Then 61 to 65. Question number 61 to 65. Number series. Now in this number series, 300, 300, 294, 270, 210. Tell me what are the differences here? The difference between 300 and 300 is 0, and next difference is 6. Here the difference between these two is how much? 24, isn't it? Next difference between these two is 60. Yes, tell me what are these numbers? 0, 6, 24, 60 can be written as 0 can be written as 1 cube minus 1 is 0, and 6 can be written as 2 cube minus 2 is 6, and 24 can be written as 3 cube minus 3 is 24, and 60 can be written as 4 cube minus 4. 4 cube 64 minus 4 is 60. Hence the given numbers can be written as n cube minus n. And the next one is 5 cube minus 5. What is 5 cube minus 5? 125 minus 5, 120. And the next number, how much should be added here? 120 should be added to this one, and 210 plus 120. And what is the answer here? 220 minus 120. 210 minus 120, the answer is 90, that is given in choice 3. Here the difference between the numbers are n cube minus n. Last year in most of the examinations the same question has been repeated. Maybe the numbers were different, but whereas the logic is one and the same, n cube minus n difference. The next one, question number 62. Now in this question number 62, now 16 to 8, number once decreased, from there onwards the number keep on increasing. Hence whenever the number decreases once, from there it is increasing. Hence what is the logic here? Now it must be 16 into 0.5. How much is that? 8. 8 and 12 can be written as 8 into 1.5 is 12, and 12 and 30 can be written as 12 into 2.5 is 30, isn't it? Into 0.5, 1.5, 2.5. Next one is how much? 30 into 3.5. What is 30 into 3.5? 90 plus 15. That is how much? 105. And 105 into 4.5. 105 into 4.5 is 472, isn't it? 472.5. Then what is the missing number here? 105 is the missing number, that is given in choice 2. The given numbers are multiplied with into 0.5, into 1.5, into 2.5, into 3.5 and into 4.5. Question number 62. then 63. Now in question number 63, the numbers are in the decreasing order. Whenever the numbers are in the decreasing order, you should always start in the reverse order, isn't it? Now start in the reverse order. Then, now 78 and 158, how can you express this one? Into 2. 78 into 2 is so much? 78 into 2 is 156, plus 2 is 158. 38 and 78. 38 into 2, 76 plus 2, 78. 18 and 38. 18 into 2, 36 plus 2, 38. And 3 into 2 plus 2. 3 into 2 plus 2 is so much? 8. Now 8 into 2 plus 2 is 18. What is the missing number here? 8 is the missing number here. In the reverse, it is into 2 plus 2, into 2 plus 2, into 2 plus 2. 3 into 2 plus 2 is 8. 8 into 2 plus 2, 18. 18 into 2 plus 2, 38 and so on. Question number 63, choice 2. Then question number 64. Now in this question number 64, now if you observe here 2, 3, 7, 22, 89 and the choices are 300, 200, 400 and so on. That means the numbers are increasing at a very faster rate. It must be under product or combination. Product is not possible between 2 and 3, isn't it? Between 3 and 7. Hence it must be 2 into how much? 2 into 1 plus 1. 2 into 1 is 2 plus 1 is 3. Next one 3 and 7 can be written as 3 into 2 6 plus 1 is 7 and 7 into 2 is so much? 7 into 3. 7 into 3 is 21 plus 1 is 22 and 22 into 4 is so much? 88 plus 1 is 89 into 2 plus 1 into 2 into 1 plus 1 into 2 plus 1 into 3 plus 1 into 4 plus 1. Next one is into 5 plus 1. What is 89 into 5? 89 into 5 plus 1 will be 445 plus 1 446. That is choice 3. The given numbers are multiplied with 1, 2, 3, 4, 5 and the next number is taken. 64. Then question number 65. 101, 118, isn't it? 101, 118. Now, sir, if you observe here in this one, the numbers, earlier we had discussed about this one. 101 to 118 number increased, again decreased, again increasing, again decreasing. Whenever the numbers are increasing and decreasing, then you should go for alternate numbers. Now 101 and 84, what is the difference between these two? Minus 17. And 84 and 67, what is the difference here? Again minus 17. Alternate number 17 is the difference. Now 118 and 135, what is the difference? 118 and 135 plus 17 is the difference. Again 135 plus 15 plus 17, 152. Alternate numbers minus 17 and the next alternate numbers plus 17. Isn't it? Hence what is the missing number here? 152 is the missing number. Or else in the straight away if you can work out this one 101 and 118, it is plus 17. Next one will be minus 34, isn't it? And next one will be 84 and this one plus 51. Next one will be minus 68. Next one will be plus 7, 68 plus 85, 17. Multiples of 17 are added and subtracted. Then what is your answer here? The answer is 150. In either way you can work out like this. Multiples of 17 are added and subtracted or the alternate numbers differed by 17. Clear? And it is given in choice 3. Done with this? Now question number 61 to 100. Any doubts in these 40 questions, 61 to 100? And the next is